So we are looking at sketching parabolas with no real roots today. So you should be able to identify a parabola that has no real roots and the conditions for that, and then be able to solve the graph as a result. So just as a quick reminder, remember when you solve a quadratic equation, essentially what you're doing is looking for the roots of that equation. And when you're looking for the roots of that equation, it's when y is equal to 0. So essentially when that graph cuts the x-axis is what you're looking for. Now, having already looked at the discriminant, okay, which is b squared take away 4ac, we looked at the scenario for when it was negative. So when b squared minus 4ac was less than 0, the quadratic graph had no real roots, or 0 real roots, which means that the parabola doesn't actually cut the x-axis at all, so it's the one where it's floating in midair. So as a result of that, then you can't find the roots. If the quadratic function, if you complete the square of the quadratic function, it makes it an awful lot easier to draw the graph. Now, just a small thing to point out is that if you square a negative number, okay, if you square anything, okay, it's never going to be negative, all right? It's just something to keep in mind before we get started. Okay, so if we take a look at this first example, all right, so if we think about the quadratic, y is equal to x take away 2 all squared plus 3, okay? So my first question is, what's the smallest value of x take away 2 all squared? Bearing in mind that last bullet point that was on the last slide. So the smallest value of x take away 2 all squared has to be 0, okay? And that occurs when x is equal to 2, okay? Because of the fact that if you square anything, it's never going to be negative. You're never ever going to get a negative number when you square it. Okay, so the smallest value of just this part here, okay, if the bracket squared, is 0 when x is equal to 2. So if I substitute the number 2 into that bracket, I'd have 2 minus 2, which is 0, square 0, which still gives you 0, which is why that's its smallest value. Okay, so it's never going to go into a negative number. Okay, so we know that the smallest value of the quadratic occurs when x was equal to 2, so we then need to find out what that associated y value is going to be. All right, and it's literally just a simple case of substitution. So when x is equal to 2, anywhere you see an x in your expression, pop in the number 2 and then evaluate it. So you've got y is equal to 2 minus 2 all squared plus 3. We already established that when we substituted the 2 into the bracket, it was always going to give you 0. Okay, so 2 minus 2 is 0, squared gives you 0, add the 3. Therefore, y has to be equal to 3. Now that there is your minimum value of that quadratic. Okay, and then as a result, your minimum turning point has to be 2, 3, using the coordinate x equals 2, and then the y coordinate of y is equal to 3, and popping it into a coordinate form. When you're sketching any graph, you know that you're going to have the Y-intercept, all right? When you sketch the graph of a quadratic that does have roots, all right, you have to find the Y-intercept as well, so it's no different even if it's got no real roots. So you know that the Y-intercept is when the graph cuts the Y-axis, so you've not went along the corridor, but you have went up or down the stairs, therefore x has to be 0. So when x is equal to 0, all you're doing is substituting in to the quadratic that you're given. Okay, so anyway you see an x, this time you're going to pop the number 0 in. Okay, so we've got y is equal to 0 take away 2 all squared plus 3. So you're going to have negative 2 squared plus 3. Now remember what we said, when we square a negative, when you square something, sorry, you're never going to get a negative answer. All right, so if you square a negative number, you're never going to get a negative answer. So negative 2 times negative 2, add the 3, then gives you y is equal to 7. Okay, and therefore your y-intercept has to be 0, 7. Now, all the information that we've got, okay, we know it's a happy parabola, okay, because it's a positive x squared. You know that your minimum turning point is 2, 3. You know the y-intercept is 0, 7. All you have to do now is sketch it, okay? X and y-axis, draw the shape of your parabola in, which you know is happy. Make sure, please, that you annotate, okay? So we've got our happy graph. Okay, x and y-axis is normal, all right, labelled. Happy graph, you've got your y-intercept at 0, 7. You've got your minimum turning point at 2, 3. And you know that x equals 2 is your axis of symmetry. okay, because normally to find your axis of symmetry you would add your roots together and half it, and that also forms the x coordinate of your turning point. But given that you know your turning point is 2, 3, then your axis of symmetry has to be x equals 2. Okay, so you've got 2, 3 for your minimum turning point here. Okay, you've got your y-intercept at 0, 7. All I would do last thing is just make sure that you label your graph. Okay, now any quadratic that's in the form in the completed square form, you're going to have y is equal to x either plus a all squared plus b, or y is equal to x take a all squared plus b. The turning point of that is going to be if you have, where are we? Okay, if you have x plus a all squared plus b, okay, your turning point is going to be negative ab. If you have x take away a all squared plus b, then your turning point is going to be positive ab. Okay, so the only thing that changes that you need to keep an eye on is the sign of your a. All right, your b is just going to be whatever your constant is at the end, all right, including the sign. Okay, on this second example, I'm just going to shorthand it a little bit. That first example talks you through background, okay, and the reason why the numbers come out to be the way they do. So for this one, we want to sketch the graph of the parabola y is equal to x minus 1 all squared plus 3. You want to show both the minimum turning point and the y-intercept as well. Okay, so I've given you a little cheat sheet on the bottom right hand corner. You want to identify the turning point, figure out the y-intercept, okay, i.e. you've not went along the corridor but you've went up or down the stairs, and you want to determine whether or not it's a happy or a sad graph. Okay, given that you're told it's a minimum turning point, you know that a minimum graph looks like that, okay, so it has to be a happy graph that we're looking at, so that's eventually what we're going to want to be drawn. Alright, if we are looking at our turning point, alright, if you take a look at the equation that we've got, alright, so we've got x take away 1 all squared, so x take away a all squared plus a number, okay, i.e. your plus b, so your turning point then has to be 1, 3, okay. To find out what your y-intercept is going to be, okay, you know that that is when x is equal to 0. So in this equation, anywhere you see an x, put the number 0 in. So you're going to have y is equal to 0 take 1 all squared plus 3. So y is equal to, you've got negative 1 squared, add 3. So y is equal to 4. Okay, negative 1 squared gives 1, add the 3 makes 4. All right, so therefore your y-intercept has to be 0, 4. Okay, now those are the two coordinates that you absolutely have to make sure that you annotate on your graph, all right, because never mind the fact that it's stated it, okay, so it does say you need to show that. So x and y axis is normal, okay, draw your happy graph in, make sure you get your turning point of 1, 3 as your minimum, and then your y-intercept. Okay, so you've got your happy graph, all right, well, your x and y axis. Desmo's not giving me my x and y on that. Okay, so you've got a happy graph and you have your y-intercept of 0, 4, which is here. You've got your minimum turning point. It did state in the question that it was a minimum, okay, of 1, 3. All right, just make sure that you label it. All right, definitely make sure that you put the coordinate in, okay, just to be in the absolute safe side. Make sure you pick up all those marks. Your axis of symmetry is then x is equal to 1 because of your x coordinate on your turning point. Okay, and then last thing would just be to label your graph just to say what it is. All right, let's do the same on this next example. So you want to sketch the graph of the parabola y is equal to x plus 1 all squared take away 1. Make sure that you show your minimum turning point and your y-intercept. Okay, so same cheat sheet as before. Okay, we're still looking to identify the turning point first, find your y-intercept, and then figure out whether it's happy or sad. Again, it's stated that it's a minimum turning point, so it's going to have to be a happy graph. All right, never mind the fact that you can see it's going to be a positive x squared if you were to expand that out. Okay, all right, so to find your turning point, okay, now we've got it in the form x plus 1 in the bracket this time, all squared, so x plus a take away b. Okay, so we've got -1, -1 for your turning point. Okay, remember your b is going to be your constant, all right, including the sign. All right, so sign belongs to the term, so it has to be a -1 there. All right, looking for your y-intercept. You know that's going to be when x is equal to 0. So anywhere you see an x, pop in the number 0. So we've got y is equal to 0 plus 1 all squared, take 1. So we've got y is equal to 0 plus 1 is 1. Okay, so you're going to have 1 squared, take 1. 1 squared is just 1. Take the 1, then gives you 0. All right, that then tells you, okay, that your y-intercept goes through the origin of 0, 0. All right, so just make sure that that's clear when you sketch it. All right, I would definitely annotate that as well. I know it's fairly obvious when it's the origin, but just make sure that you annotate it to be on the safe side. Okay, so again, as usual, you're going to have your x and y axis. All right, you've got a happy graph. There's your y-intercept here. Okay, it does look a bit odd because it does go through the origin. All right, make sure that you label it. You've got your minimum turning point of -1, -1. All right, your axis of symmetry is x is equal to -1 for your purple dotted line. And finally, just make sure that you have got a label there for what graph it is that you're sketching. Okay, let's take a look at this one. So sketching the graph of the parabola y is equal to x squared plus 6x plus 10. All right, again, showing the minimum turning point, so you know it's a happy graph. Okay, so straight away you know it's going to be that one. And then you also need to show your y-intercept as well. Okay, so you still want to find the turning point and the y-intercept. The only difference with this one is that it's not in the format that you want. Okay, so we've got y is equal to x squared plus 6x plus 10. All right, you're going to want to complete the square on that first of all. Okay, so completing the square we've already met. Okay, so we've got x plus 3 all squared plus 10, and then take the 3 squared off. Okay, 3 squared makes 9, 10, take 9 gets you to 1, so we've got y is equal to x plus 3 all squared plus 1. All right, from there you can then do turning point and y-intercept. Okay, so your turning point this time, we're looking at x plus something inside the bracket, so your turning point is going to be -3, +1. And then for your y-intercept, as usual, okay, you've went nowhere along the corridor, but you've went up or down the stairs, so it's when x is equal to 0. So anywhere you see an x there, pop in a 0. So you've got y is equal to 0 plus 3 all squared plus 1. All right, 0 plus 3 is 3, square it, gets you 9, add the 1 gets you 10. So y is equal to 10. All right, so therefore your y-intercept has to be 0, 10. So from there, make sure you sketch your graph. X and y axis is normal. Make sure you annotate with your turning point and your y-intercept. All right, and we already know it's a happy graph because we're talking about a minimum turning point. Okay, so as follows, again, x and y axis. Okay, you've got your y-intercept at 0, 10. You've got your turning point of -3, 1, which means that your axis of symmetry has to be x is equal to -3. Okay, you've got a happy graph there, a happy parabola, and then last thing to do is to state which graph you are sketching. If you had labelled it with the completed square form, it doesn't make any difference, just make sure that you do label it. Okay, so we've looked at sketching the graph of a parabola when you've got no real roots, i.e. when your discriminant is less than 0. Okay, so it doesn't actually cut the x-axis, so it's one of the graphs that floats in midair. All right, you need to be able to identify that parabola when it's got no real roots and then be able to sketch it. All right, more often than not you'll be given it in completed form. You might not be given it though. Okay, so you might have to complete the square on it first before you find the turning point and the y-intercept. Make sure please that when you sketch the graph, just the same way that you would when you're sketching any other parabola, make sure that you annotate it fully and make sure you don't lose any marks. All right, if you need any more resources on this to do a little bit of practice, make sure you go on to the National 5 Google Classroom.